So again, we've already looked at our sequences in series. In particular, we look at the arithmetic sequences on Friday. We can find the sum of an arithmetic sequence with n terms. It's just given by the formula. Capital S sub n is equal to n over 2, where n just represents the number of terms, times the quantity of our first term, a1, plus our last term, a sub n. That's all we have to do to add up the entire particular arithmetic sequence. So, here we have want to find the sum of 40 plus 37 all the way down to 22. Is this arithmetic?
Yes.
How do we know? Difference is what? Negative 3. Don't forget, it's negative 3, not positive 3, because we always do a2 minus a1, a3 minus a2. So as Mara said, we have a difference of negative 3 for each of these terms. It is arithmetic, and we know that we can use, how many terms do I have here?
7.
So to find my sum, my n equals 7, again, my n over 2, so 7 over 2, times my first term, plus my last term, so here we come up with the sum of this arithmetic sequence, 217. If we wanted to, could have just done 40 plus 37 plus 34 plus 31. Come up with the exact same answer.
Hey, how'd you get 7?
Here to here. 62 is 31 times 2. Right, so just cancel out with that 1, 2 down there, so it's just 7 times 31. Any other questions? What about adding up the integers from 1 to 35? Well, first of all, what is my n? 35. Right, so here we have our sum. 35 over 2. My first term is?
1.
My last term? 18 times 35. Sorry? No, I just asked what was it. Sure. I think so. Perhaps? How about 600? We know how to do the simple multiplication, folks. We don't have to rely on the calculator, right? Again, especially since there is no calculator tomorrow.
What?
It isn't so. If you guys have difficulties multiplying 35 times 18 without the calculator, I think we should be taking the calculator for quite some time. So make sure we get those skills on up there. So here we're going to add up the integers from 1 to 57. So what do I write? 57 over 2 times. So that gives us as 57 over 2 times 58. Or again, 58 canceling with my 2, leaving behind 29. So I have 29 times 57.
1,635.
1,653. What's that? Again, all you're doing is, your 57 times 29, the 2 rows, multiplication type stuff. Yes.
Why are you sure this one is SN and the last one is S35? Isn't N here 57?
N is 57, correct. I just put down the N instead of 57 for whatever reason. What about this one? What is my N? My N is N. Capital N. It's not infinity, it's capital N. So here we're looking for the sum all the way up to capital N, giving me what? And then what? We go on to the next problem. That's all we can do. Unless there's actual numbers, we're coming up with something simplified in this case, no. So, that's what we do when we want to come up with the sum of an arithmetic sequence. If we have an infinite sequence, we can actually talk about a partial sum, where we're not going to necessarily add up every single term, but in this case, if you want to look at this first n terms and sum those up, that's something when we talk about the nth partial sum. Again, if I have an infinite sequence and I just want to add up the first 20 terms, that's the 20th partial sum. So the nth partial sum can be found by using the same formula for the sum of our finite sequence. Which was just our n over 2 times a1 plus a2. So it doesn't matter if we're looking at a finite sequence or if we're looking at the nth partial sum. We're still using that same n over 2 times the first term plus that last term. So here we want to find the 50th partial sum of the arithmetic sequence. Again, I'm still going to use this the same formula, n over 2 times a1 plus a sub n. What is n? You found it? Absolutely. I'm looking for the 50th partial sum. I'm looking just from the adding up all of the sum, all of the terms on up to 50. That's what it means again, 50th partial sum. Do I know my A1? What about my A50? That's not what you're trying to find. You're trying to find the sum all the way up to the 50th term. But I need to find, from a formula, I need the 50th term, don't I?
Right.
So, how do I find the 50th term? Somewhere. Remember from Friday, right? When we talked about the arithmetic sequences, for the nth term, a_n equals dn plus c. Do I know what d is? What is d? Right. I have my 6 minus 2, which is 4. 2 minus a negative 2, negative 2 minus a negative 6. Right, my a4 minus a3, a3 minus a2, a2 minus a1, all the same. D of equaling 4. Do I know my c? Can I find c? Remember, c equals a1 minus d. Our a1 is negative 6. D was at negative, positive 4, so subtracting giving us negative 10. So now we know our a sub n, the formula there is what?
4.
4n
Minus
minus 10. Right, this is what we did on Friday as far as this gives us our equation for the nth term of an arithmetic sequence. Right. And the ultimate thing that we're trying to get here, or the intermediate step, we're trying to find what is that 50th term. Which gives us. So now I know my 50th term. We know our first term, and we know n. So can we calculate this partial sum? Absolutely. So first we had n over 2, so 50 over 2. And our a sub 1, where'd it go? And our last term, 190. Question?
I assigned to 190 over 2.
So here we have our 25 times. Go. How do we come up with that? 184 times 25, right? What's 25 times 4? Nice number, isn't it? Can I pull a 4 out from 184? What's 4 into 184? 4 goes. Look for patterns sometimes, especially when you're not using a calculator, right? If you recognize 25, I know 4 of those make 100, and 100's a lot, very manageable when we're multiplying. Can I pull a 4 from that 184, whatever number, and then I'm just adding 2 zeros at the end. Look for stuff like that. You don't have to, folks. Definitely you can go ahead and do 184 times 25, like you learned in elementary school. Nothing wrong with that at all. However, if you want to be able to do this stuff, this is like mental math, right? Being able to do this in your head versus, question. Goes along. Okay, what are you talking about? Okay. What about something like this? So here we want to determine the seating capacity of an auditorium. There's 30 rows of seats. There's 20 seats in the first row, 22 in the second, 24 in the third, and so on. So, what are they asking us for? How many seats in the entire room? In the entire auditorium. So they're adding us to do what? Add up each row. So in other words, we are looking for, how many rows are there? So they're asking us to find S30, right? Adding up the first row, second row, all the way up to the 30th row. Do I know N? N is 30. I know A1.
20.
20. Do I know A30? I have to find that. So how am I going to find my A30? Do I know D? Right. Starting off with a 20 seats, then 22 seats, then 24 seats. We're increasing by 2 each time. It has a difference of 2. So now to find the C, somebody other than Mario? That's my A1 minus D, so 20 minus 2, giving us. So then our A sub N becomes what, Abby?
2n plus 18.
Absolutely, 2n plus 18. So now I can find, what is that, A sub 30, yeah? I'm sorry? Absolutely. So utilizing formula for our nth term, we're able to come up with our a sub 30 equals 78. Are we done? That just got us that particular term, the last term. So now we can go ahead and do our S30 sum. Again, my n over 2 times the first term. A1 was what? 20. And the 30th term, right? We just determined 78. Giving us 15 times 98. Which is a very easy one, right? Doing it in your head. I'm serious about doing this one in your head. It's all about mental math again. Most of you are probably trying to do 98 and putting the 15 underneath that and doing 5 times 8, 5 times 9. No? How should we do something like this one? What does it mean 15 times 98? How many 15s am I adding up? I'm adding 15 98 times. What happens if I add 15 100 times? How many extra times did I add it up? So I need to subtract those two 15s. So what's 100 times 15? Mental math. You guys don't have to use these things. I'm showing you, but I do find them very useful, especially when you're not using it. Right? So here we come up with 1,470 seats. Question. Here we want to consider job offer, starting salary of $32,500, annual raise of $2,500, determine the total compensation for 6 years of employment. Again, what are they asking us for? What are they asking? Mario said they are asking us for adding up each year. Not just what are we getting in the 6th year, but adding up years 1 through 6. That's what they're asking us for. Right? So, we know n is 6. Our A1? 32,500. What about our 6th term, our last term? We have to find it. So how are we going to find it? Going between my first term and my 6th term, from the first term to the 2nd term, I added 1d, right? Common difference. Then I added another d to get to 3rd, and so forth. So I've added my difference 5 times, right? You guys? So, do I know what A6 is? No, but that's what I'm looking for. Do I know A1? What is A1? 32,500. Right. And what is my D? Right, that's what we had that annual raise of 2,500. That's my common difference. So is using the formula incorrect? No, not at all. using our formula, we already know what D is. D is at 2,500. And then to calculate my C, A1 minus B. Right? We can find that. And then we can go ahead and substitute our n equals 6 to come up with our A sub 6. But again, using just this relationship here, understanding what's going on, I can use that relationship and say, okay, A6 is just $45,000. So now, can we calculate this? So I have my n over 2 times the first term plus the last term. Right? No tricks here, just multiplying by 3. So here we come up with $233,500 for the total compensation for those 6 years. Questions? Finishes up 9-2. Arithmetic sequences. Quiz again tomorrow. Ask questions now. Don't ask them during the quiz tomorrow. Yes.
So there will be sums,
Sums?
Okay. What was that entire unit called? 9-1. What was it?
9-1 was sequences.
Sequences. Okay.
So within the sequences, we had 2 different things. We also have to talk about the summation symbol you're talking about, and also we talked about, I believe we had factorials in as well. Yeah. Right, so we had the factorials and the summations. In particular, the sequences, that's where we had our, this was 9-2 or 9-1? Our AN equals, I can't know the sections, but right. So that's where we just talked about the sequences coming up with first term, second term, third term. And then also talking about the series as far as adding them up. Pretty much it all culminates to everything you see today, right? Questions? All right.